So in this unit we're going to be talking about scientific notation as opposed to decimal notation, which is what you probably think of as ordinary numbers. And what do I mean by scientific notation? I mean a number written in this format. So it's something times 10 to the something, and n can be any integer, so any whole number. We can have names for these different parts of it, so this we're going to call it the coefficient. There are different names, and then this whole piece we're going to call that the power. Talk about powers of 10. So 10 is the base, we're working in base 10, base, and then n, let's call that the exponent. And as I say, this can be any whole number, positive or negative. So if I say times 10 to the n, what do I mean? So that's equivalent to saying that we're multiplying by 10 n times. So for example, if we say times 10 to the power 4, that's the same as saying times 10 times 10 times 10 times 10, 1, 2, 3, 4 times. Then we'd multiply all those together, so that's 10,000, so that would be our ordinary number, if you like, in quotation marks. Okay, so there's kind of our definitions. Let's work through some examples. So let's look at converting between, let's say, converting from scientific notation to decimal. Notation or ordinary. So for example, let's say we've got 5 times 10 to the power 4, so that's 5 times 10 times 10 times 10 times 10. If we multiply all those together, we get 50,000. Or for example, if we've got, we can do it the other way around, so if we've got 1,000, that's equal to 1 times 10 times 10 times 10, which is 1 times 10 to the power 3. If we've got 2.5 times 10 to the power 5, so that's 2.5 times 10 times 10 for 5, so that's 250,000 if you multiply them all together. Here's an example that should be familiar to you. How about 6.022 times 10 to the 23? So that's 6.022 times 10, 23 times, and that is equal to 6022. I think that's right. But anyway, a really big number. So now you're starting to really see why it's useful to have scientific notation rather than losing track of all these zeros. Don't count them up, I might have copied it out wrong. Which just proves my point. Cool. So that's how that works, but there's a shortcut. Instead of writing all this out, all the tens in the middle. So for scientific notation to decimal notation, move the decimal point n spaces to the right. So let's have an example to show you what I mean. So let's use this 1 times 10 to the 3. So that is the same as saying 1.0 times 10 to the 3, remember? So you can add the zeros after the decimal point without changing the value. So now what do? I say 1.0, and I want to move the decimal point 1, 2, 3, spaces over, and then I fill in the zeros. So that's 1,000. Put the decimal point there at the end. And yeah, if we use this example as well, so that would give us 2.5 times 10 to the power 5. So that is 2.5, and then we'd go 1, 2, 3, 4, 5. Fill in the zeros. So 250,000, just like we saw over here. And again, we can do it the other way around if we want. So how about if we've got 3,500. In fact, let's write the so this is going the other way, so that's the decimal notation to scientific notation. So then you'd move the decimal point n spaces to the left. This is only for positive n. You'll see that if n is smaller than 0, then the rules are slightly different. But anyway, here we go. We've got 3,500. And the decimal points here at the end, we go 1, 2, 3. So that gives us 3.5, because the decimal point ends up here, times 10 to the 3.